Hey guys, welcome back to IC Chris, where it's never too late to have an IC moment. I just want to say thank you to everyone who has subscribed to the channel. If you haven't subscribed, please consider subscribing. The last time I checked we were on 175 subscribers. I just wanted to let you guys know that if we hit 250 subscribers before the May-June exams, I will do 2 live Q&A sessions where I can help you guys reach your goals. So you help me reach my subscriber goals, and I'll be helping you guys reach your goals for the May-June exams. Okay, so today's video we're going to be looking at physics. So I'm doing the past paper for May-June 2021, and I'll be covering question 2. Enjoy. Okay, so question 2, an 8 kilogram block on a rough surface is connected to a 2 kilogram block by a light inextensible string passing over a frictionless pulley. As shown below, the 8 kilogram block moves at constant speed. Okay, so note the constant speed there. When pulled at 29.6 newtons horizontally with horizontal force to the right. The friction force acting on the 8 kilogram block is 10 newtons. Okay, so then give us the picture over there. So 2.1 is just a definition. I'm not going to be covering the definition over there. So 2.2 says draw and label a free body diagram of the 8 kilogram block. Okay, so if we have a look at the 8 kilogram block there quickly, if I draw the free body diagram, okay, so to the right we're going to have our applied force, F applied. Okay, to the left we're going to have the tension of the string, Ft. Remember, we also have friction, and friction is always opposite to the motion or the applied force. So F of friction. Then we're going to have our normal force. Okay, don't forget about that. And even though it's sitting on a table, we still have the force of gravity applied. Okay, so if you just label everything here, okay, that's going to be applied. Okay, then Ft is going to be tension. Let's see, F is then going to be friction. Fg is gravitational force. And then Fn is your normal force. Okay, so nothing too complicated there. Okay, now looking at 2.3, it says calculate the tension in the string. Okay, so just as I've stated over here, it says constant speed, therefore your acceleration is 0. So using Newton's second law, we have F net equals to mass times acceleration. Okay, for this we're just going to be using the 8 kilogram block. So we're going to have force applied, which is acting to the right. So I'm going to take that as positive. So F applied. Now I'm going to minus the sum of all the forces acting to the left. Okay, so everything acting to the left is going to be my frictional force plus my tension force. Okay, and that's all going to equal to my mass times my acceleration. Okay, mass is not a vector, sorry about that. Okay, so then we're going to have, let's see, that's 29.6 newtons minus your frictional force, which is 10 newtons as given. We want Ft, okay, and then this is going to equal to 0 because my acceleration is 0. Okay, so if we sort out everything, we're going to distribute the minus into the bracket, and then I'm going to take Ft over, so we'll have 29.6 minus 10 equals to Ft, and therefore Ft is going to equal to 19.6 newtons. Okay, let's just have a look here. Yeah, there we go. Okay, so your tension force is 19.6 newtons, and that will be acting to the left. Okay, then if we look at the next part for 2.4, it says now that the force applied is changed from 29.6 to 50 newtons. So it says apply Newton's second law to each of the blocks and calculate the magnitude of the acceleration of the 8 kilogram block and the tension in the string. Okay, so for 2.4.1, I just want you guys to note that the tension force acting on the 8 kilogram block and the tension force acting on the 2 kilogram block are equal to each other. Okay, even though for the 2 kilogram block it's acting up and for the 8 kilogram block it's horizontal, they are still equal to each other. Okay, so let's see how we're going to go about doing this one. So I'm going to set up my simultaneous equation for each block. So F net for the 2 kilogram block equals ma. Also note that my acceleration is not 0 anymore because I've increased the applied force, so now we need to find that acceleration. Okay, and then F net equals ma. Okay, so for the 2 kilogram block we're going to have my tension force, okay, minus my gravitational force on the 2 kilogram block equals to my mass times acceleration, and then the same for this side. It's going to be a repeat of question 2.3, so it's just going to be F applied minus F of friction, and then that's going to be plus F of tension equals to mass times acceleration. Okay, so we want Ft at this point in time, we don't know what it is. This is going to be minus, let's have a look here, that's going to be 9.8 times 2 kilograms, okay, equals 2a, and this one over here is going to be 50 minus 10 minus Ft equals to 8a. Okay, so now I'm going to make Ft the subject for each one, and then Ft equals Ft. Okay, so by doing that we're going to get the following. We're going to have 40 minus 8a is going to equal to 2a plus 9.8 times 2. Okay, now if you sort out the algebra over here, the 8 is going to come across, that's going to go over. You will get an acceleration of 2.04 meters per second, and that would be squared. Okay, so now looking at 2.4.2, it says calculate the tension in the string, okay, between the two blocks. Okay, so now we want Ft, so we now have the acceleration. Okay, we now can use any of the ones that we've created up here to find our tension. So I'm going to use the simplest one for the 2 kilogram block. So 2.4.2, we're going to have Ft minus 9.8 times 2 equals to 2 times 2.04. Okay, and if you plug this into your calculator and you sort out all the algebra over here, you should get an answer of your tension force equaling to 23.68 newtons. Okay, and that's how we go about doing this question.
Okay, if you guys did enjoy today's video, then please leave a thumbs up on the video. It does help me a lot. If you have any questions regarding this question, question 2, leave them in the comment section down below and I'll get back to them as soon as I can. Just a reminder again that if we do hit 250 subscribers before May-June exams, then I'll be doing those live Q&A sessions, so let your friends know about the channel, especially if the videos are helping you. And remember, it's never too late to have an OIC moment.